Hello, everyone. Welcome to the last session of CTBUH 2011. This is the last session, and those of you who are here in this hall are the real hardcore tall building professionals. Thank you very much. My name is Jaepil Choi. I'm the moderator of this session, which will be a summarizing and concluding session for the conference. Please, let me introduce the invited panelists for this event. Mr. Sabah Al-Reyes, founder and managing partner of PACE, Pan-Arab Consulting Engineers. He is from Kuwait. Please welcome Mr. Al-Reyes. Please come to our podium. By the way, the simultaneous translation is available. So if you turn your channel to 1, which will be Korean, and number 2 is English. Our next speaker is Mr. Kyung-Jun Kim. He is the head of the building unit and an executive vice president of Samsung C&T Corporation. He is a building construction expert. Please welcome Mr. Kim. Now we have Professor Yukio Tamura at School of Architecture and Wind Engineering, Tokyo Polytechnic University, Japan. His specialty is wind engineering. Please welcome Professor Tamura. Last but not least, let me introduce Ms. Cathy Yang, Vice President of TAIPEI 101. She has an extensive experiences in development, property management, as well as the other areas. Please welcome Ms. Yang. Now we have here 4 panelists from various fields of expertise. You may have noticed that an architect is missing. Someone was scheduled to be here, but he came across an urgent matter just a week ago and had to resign from our list. But no problem. We do have an architect on this podium. Can you guess who? I am. Thank you. Also, Mr. Leslie Robertson was supposed to be here, but he is ill. After 2 days of his enthusiastic involvement in this conference, he wants to convey his sincere apology to us. So there are 5 of us here on the podium, and let's get started. I'd like to begin with our roundtable session with a big question. Why tall? More specifically, what are the benefits of the tall buildings from the point of view of your own expertise? What are the challenges we face in designing and building of high-rises? Each of the panelists would take turns to speak for 5 minutes maximum. And Mr. Al-Reyes, would you start your talk? Thank you.
Well, I asked myself this question many times, why tall? But I think this morning I've heard Mr. Professor Abbas Amin Mansouri covered the subject very, very well. And I think that whatever, in that paper is the subject of what we're talking about. Well, I come from an area where we're only are 4% of the total world, but we produce 60% of the oil. And energy is fuel. Is very, very cheap. So there is, you could say, for developers, there's no justification, or they always look at it as, why do I have to really build tall green buildings? Saving in what? Energy fuel cost us gasoline 16 cents, while a bottle of Evian cost $1.30. So that's, this is one of the problems we are facing is, everything has to be justified economically. And when you talk to a developer and you cannot justify it economically, that you really want to introduce green solutions that are initially more expensive, but in the long run, they're justifiable and they will pay for itself. He thinks, first of all, about the initial cost more than he thinks in the long run. And this is one of the problems that we are facing. Now, why tall buildings? Of course, everybody knows that there is so much advantages of building tall. You save in energy, you save in infrastructure, and so on. And this subject has been covered so much. But I think, in my opinion, tall buildings have been abused. And really, we have not yet come yet to the core problem that probably will be faced with in maybe 10 or 15 or 20 years. Mind you, only 4% of the tall buildings that are being built today are really worthy of staying 20 or 30 years. Imagine, 96% of the probably the buildings that we're building today has to be taken down in 20 years. This will be a major problem because really a lot of the buildings that we're building are not sustainable. Yes, you have very good examples like Burj Dubai, Burj Khalifa, and so on. You have really beautiful international consultants that really do a fantastic job. But look at the rest. 96% of the buildings that are being built are not worthy of staying. How are we going to get rid of those? You know, this is the question. The problem is we think that, yes, tall buildings is nice. A lot of it is ego-driven. And I'm talking out experience. I've been in this business for 43 years. And I built so many, designed so many, associated with so many. And I've sat in both sides. And I see how developers, think. The problem is we have two types of developers. We have the government, which really doesn't care how much it costs, but whether it's government or government-owned companies. Those are the ones that have really, you could say, deep pocket, and the rest are developers, and most of the small developers really are thinking about something that they could, how soon can I finish this building? How soon can I rent it? How soon can I get my return? And in 10 years, the hell with it. This is the attitude we're seeing, and this is the problem I think we're going to face in the next 10 to 15 years, and mark my word for it. Of course, there are so many advantages of tall buildings. It's a noble invention, and everybody got into this issue of building tall and taking it as well. In order for us to be more civilized, we have to build more tall buildings. And I've seen it in Kuwait, I've seen it in Abu Dhabi, I've seen it in Dubai, I've seen it in Bahrain. Unfortunately, also you have very bad examples that, take the building of the World Trade Center in Bahrain. Unfortunately, well, designed by Atkins. It's beautiful consultants, and they did a fantastic job in most of their work. But this job is really a disaster. It doesn't set a good example of, again, you want sustainable building, you want really something. And look, 3 turbines have not performed yet, and since 2007, now 4 years. And so maybe I'm a little bit hard on the tall buildings. I love tall buildings, and I think really they are the answer for many many of our problems. But unless really we look at that, look in the code, and I think really as a Council on Tall Buildings, and I put that in one of my articles in the journal, is that we really have to name the best, but also we have to name and shame the worst, because they are not doing us good. As a professionals, we feel that there are a lot of really designers that are not doing our profession good, and it will be disastrous. Some of those buildings that, 50-story building that has to be taken down very soon, and so I'm talking about now the Middle East. I'm talking about Kuwait. I'm talking about Dubai. And this probably goes, through the world. But from what I've seen, the euphoria we had in Kuwait, we had in Dubai, in Abu Dhabi, in Riyadh, in Bahrain. Just look around and see how many really of those tall buildings are sustainable. Thank you.
Thank you, Sabah. Well, obviously, he's from the region where the many tall buildings are sprouting up nowadays, and we really appreciate his candid comments on what's going on there and some of the problems that he is experiencing today. Let's turn to Mr. Kim. He was in charge of the Burj Khalifa construction. So what can you learn from your experiences?
Good evening. I believe this tall building can bring many different the meanings to the people. For example, this Petronas Tower is the design is for representing the gate of the Kuala Lumpur. When this project was completed, really encouraging all the Malaysians, and they believe they can do something towards the Awasan 2020. But again, this Burj Khalifa, this is the tallest building, but even in height, but again, this can provide a lot of benefit to the city, and even this developer Imar, they can get a lot of benefit from within this downtown Burj development. I believe I'm the only one contractor and builder around this table. Maybe I can talk about a little bit this tall building construction point of view. This tall building planning and the design and construction takes 7 to 10 years. It's a long-term project. So really this time management and cost management is essential and very important. And I would propose this main contractor's early involvement can bring a lot of benefit to the client. For example, the tall building has a very unique structural system, like Petronas Tower Sky Bridge, and the Burj Khalifa, this spire and pinnacles. When we finalized the building height, there was a series of meetings with the client and also with the designer to finalize the building height and also the building structural systems. So actually we developed construction method and we present to the client and the designer and discuss together what is the best way, because of there is a safety concern and also logistic concerns. So through this workshop, we can find the best solution, safest way. That's why we are able to complete this spire and pinnacle without having any technical or safety issues. So especially this tall building, there we have to consider many issues. For example, this the wind during the construction. If we build this 30, 40-story building, then there is no serious impact. But all the major activities happen above the 600-meter height, then there's a serious wind impact. So when we plan the construction schedule, we have to consider this kind of impact. When we make a detailed schedule about the spire and pinnacle, we assume this we can install this curtain wall, maybe 70% of the working days. But actually, the climate and the wind situation was completely different. Even the ground level, there was no wind, but if you go up to the above 600 meters, then there was a strong wind. So actually, we are not able to continue our construction activity due to this strong wind, almost 50% of the working days. So I believe this, all the proven, tall building technology, including the structural systems and materials and vertical transportation and all the building automation system, all this kind of proven record will be the base for the future tall building construction. So I believe this tall building construction itself is another challenge. Thank you. Thank you very much.
Thank you very much, Mr. Kim. We've heard his vivid experiences in the construction of tall buildings, and we do have some problems at the moment, but we all hope that in the near future, well, somebody said last night that the tall building professionals are rough in teenagers at the moment, and we'll grow up and we're going to solve lots of problems at the construction and even before the construction in designing and planning level too. Professor Tamura, please tell us about your experiences as a wind engineer. I mean, Mr. Kim just mentioned the wind problems in construction site. So you're going to talk about that and after the designing stage too?
Mm-hmm. Yes, already talked about wind effects during construction. So I struggled to find the benefits of tall building construction in the wind engineering field. We cannot find the positive answer. So I could find only the challenging matters we face in construction. So, so if probably you know that during storm, typhoon, or hurricane, the wind speed level reaches almost 80 meters per second to 90 meters per second by typhoon or hurricane. And if the building is becoming higher and higher, due to the profile of the wind speed becoming higher and higher at the top of the building. So that means that the wind loading load effects become more significant. And also, if the building is becoming slender, it becomes more wind sensitive due to the common vortex shedding. Crosswind response becomes predominant. So it's more difficult to construct the high-rise building. And also the urbanization with the densely spaced building in the city area causes some environmental problems. Not only the pedestrian level wind, but also the quality of the air can be damaged. But only one advantage I could find in wind engineering field is if you construct a super high-rise building, merging the surrounding area into the one high-rise building, leaving the surrounding area as empty space, and such an if you make undulation of the height of the building in the urban area, the urban ventilation can be improved. But if you construct almost the same level of high-rise building, densely spaced, it causes some heat island problem or air quality, contamination of the air quality, such a problem happen. But the super high-rise building can improve such a situation. So that is only one benefit of tall building construction I could find. And then there are many problems in the construction of high-rise building. You're very interested in to see the statistics of the complaint rate of tall building construction in Tokyo. This was collected by Tokyo Metropolitan Office. The number one complaint came from sunshade problem. Number two, the privacy invasion. And the number three is wind problem caused by high-rise building, downwash phenomena and separated shear layer channel flow phenomena causes strong wind condition, a discomfort situation happen in pedestrian level. And another one is acoustic noise caused by strong wind, especially for the residential building. And habitability to wind induced vibration, especially for seismic prone region. The tall building is constructed rather flexible and lightweight, but that means vulnerable to wind. So daily wind causes some problem due to the vibration. But in this year, we had a very strong earthquake in March, and also the strong typhoon attacked Tokyo area. So it's maybe recurrence year, 30 year or so forth. The vibration was perceived by many occupants or people in the high-rise building. But no complaints happened because they know that this is a very special occasion. Typhoon and earthquake can vibrate the building. But if the vibration happened due to daily wind, for example, spring storm and so forth, they give complaints. So daily wind comfort is also very important. And to solve this, the damping device is very effective, and many tall buildings in Japan install damping devices. Maybe more than 3,000 or 4,000 buildings install such devices. Because in Japan we have very strong earthquake and strong typhoon. So both we should, for typhoon, strong wind, the building should be designed massive and stiff, but earthquake lightweight and soft, flexible. So quite opposite direction we should go. So damping device is only the way to improve the situation. So damping devices are used, and recent trend of the damping devices is different from the early stage of application of the damping device in Japan. Early stage we tend to use mass damping system for habitability level, but recently people are concerned about safetiness against seismic force. So recently passive viscous damper, oil damper, viscoelastic damper becoming popular, and also steel damper became very popular. And in-frame type is better and preferable, and it becoming popular. The mass type damper is only effective for wind, and they require some additional space. So that the new trend is such a passive type. And also the multiple different types of damping devices are used for different purposes. Early stage of application, only one damper was installed in one building, but now 2 or 3 or 4 different types of damper are used for building to suppress vibration. And also I like to emphasize the importance of the change of the configuration of the building to improve the aerodynamic characteristics, especially for crosswind, and twisted and some taper, the setback, a lot of configuration proposed, and also combined type also used, and very useful to reduce the vibration. So that is a kind of damping method by changing the aerodynamic coefficient. So taller and longer and lighter causes more and more wind-sensitive and wind-sensitive situation. So trend is not good for wind engineering, but wind engineers, very beneficial because more and more business chance for wind engineers. That is the current situation.
Okay. Well, thank you very